Assalamualaikum Encik Saifullah. We are from 2BEZ Section 1. This is our lab report for Lab 5. My name is Azwa Syazwani.
And my name is Huzaimah. In this lab, we are required to study characteristics of OM voltage regulator, full wave rectifier circuit, and the impact of capacitor filter to the ripple voltage and also voltage regulator IC.
In part 1, we are required to find the voltage across R4 when Zener diode reach its voltage point, that is 5 volt, by calculation, and the voltage at R4 is 7.65 volt. This is the circuit of op-amp voltage regulator circuit that we have constructed in multisim by setting the V1 minimum value 1 volt and maximum value is 15 volt with increment of 0.5 volt or equal to 3.5714%.
This is the table of the recorded data. From the table, the voltage of R4 when V1 is increased with increment 0.5 volt is recorded in this table A. We can see that when V1 is increasing, VR4 also increasing starting from 1 to 7.616 volt. Besides, the voltage of R4 at 15 volt of V1 is almost same with the calculation when the Zener reach its voltage point. This is happen because the OM in the circuit is act as comparator. R1 and R3 is the voltage divider network used to sense any change at output. The change sent by the divider network is sent to the inverting input at the comparator, while reference voltage held by Zener diode at non-inverting input of OM is applied to the base of transistor that act as a gate of the transistor. If the output voltage decrease, the increased base emitter voltage cause transistor Q1 to conduct more, thereby raising the output voltage, maintaining the output constant. If the output voltage increase, the decreased base emitter voltage cause transistor Q1 to conduct less, thereby it reducing the voltage output by maintaining the output constant. In part 2, we are need to identify the full bridge circuit, voltage smoothing filter, and voltage regulator circuit from the circuit of full bridge voltage regulator circuit. The full wave bridge circuit is using diode give us a greater mean DC value which is 0.637 Vmax with less ripple, while the output waveform is twice that of the frequency of the input supply frequency. The smoothing circuit, which is contain capacitor, is converting the full wave ripple output of the rectifier into more smooth DC output voltage.
This is the circuit that we have constructed. From this circuit, we need to measure the ripple voltage and capture the output for each circuit using oscilloscope and tabulate the data. Then we are required to replace the smoothing capacitor with 220 microfarad capacitor at the LM7805. The result also tabulated. Based on the table, as we increase the value of capacitor at smoothing filter from 10 microfarad to 220 microfarad, the voltage smoothing filter also decreased from 1.42 volts to 125 millivolts. We also can see the effect it has on the rectified output waveform. Here, the 10 microfarad capacitor is charged to the peak voltage of the output DC pulse, but when it drops from its peak voltage back down to 0 volts, the capacitor cannot discharge as quickly due to the RC time constant of the circuit. With the capacitor value is different, we can see the effect it has in the rectified output waveform. maintaining the voltage across the load resistor until the capacitor recharges once again on the next positive slope of the DC pulse. In other words, the capacitor only has time to discharge briefly before the next DC pulse recharges it back up to the peak value. Thus, the DC voltage applied to the load resistor drops only by a small amount. But we can improve this still by increasing the value of the smoothing capacitor. Here, we have increased the value of the smoothing capacitor from 10 microfarad to 220 microfarad, which has reduced the ripple, increasing the minimum discharge voltage from the previous. The effect of supplying a heavy load with a single smoothing or reservoir capacitor can be reduced by the use of a larger capacitor which stores more energy and discharges less between charging pulses.
In part 3, we need to construct circuit of adjustable voltage regulator circuit by using multisim. This is the circuit that we have constructed.
From the circuit, we need to adjust the potentiometer until get 5 volts at VR1, and the resistance value of R3 is recorded as well as the voltage of R3 and R2. Then we also need to record for other value of VR2. All of this data is tabulated in this table.
From this table, as we increase the VR1 by 0.5 volt by adjusting the potentiometer, we can see the value of R3 and VR3 also increase while the value of VR2 does not change. We also increase the potentiometer until its max rotation. The value of R3 and VR3 also increase, but the value of VR2 decreased with 1.789 volt.
That's all from us. Thank you.